So in this video, we're going to look at graphing the exponential function, and in particular, transformations applied to the exponential function. So here we're asked to graph the following function. Our function is y equals -3 times 2 to the power x minus 1 plus 2. So the first step is to determine what our base function or a parent function is. So in this case, our parent function is y equals 2 to the power x. Okay. So we want to have an idea of what that function looks like, and then we're going to apply our transformation. So what are the transformations applied to our base or parent function? Well, we have a negative here, we have a 3, we have a -1 and a 2. So what do each of these numbers or these values do? So the negative out in front, this is a reflection, a vertical reflection in the x-axis. Right, the 3 is a vertical stretch of a factor of 3. Factor 3. This -1, the -1 added to the x is a horizontal translation right 1 unit. And finally, the 2, the +2 at the end, is a vertical translation down 2 units. All right. So we have a lot going on, and all those transformations are being applied to this function y equals 2x. So let's have a look at what this function y equals 2x looks like. Okay, so let's go down here and let's draw a graph. A little graph. Okay. And y equals 2x. Right. So where is the y-intercept? The y-intercept occurs when x equals 0. When x equals 0, 2 to the power 0 is 1. So that's our y-intercept. Now this is an exponential function, so we do have an asymptote. We have a horizontal asymptote, and where is that horizontal asymptote? The horizontal asymptote is the line y equals 0, so it's the x-axis. That's convenient. And where is the asymptote? It's actually in the negative x direction. So the function gets closer and closer. Let's clean that up a little bit. The function gets closer and closer to the x-axis, but as x gets more and more negative, but it never actually touches the x-axis. And as x gets larger in the positive direction, the function y itself gets larger. So this is what our function or base or parent function looks like. Y equals 2 to the power x has this form of a curve. Okay, so now we need to apply all those transformations. Let's see, the first transformation that we can apply, so actually let's go down and let's draw another set of axes a little bit bigger, a little more space to take into account all our transformations. The first thing we can do is our vertical stretch of a factor of 3. So if we go back to a graph of our base function, the y-intercept is a nice point to use. So when we stretch vertically by a factor of 3, that y-intercept is going to also be stretched, and we're going to end up at 3. Our new y-intercept is going to be, let's mark off some points here. It's actually going to be at 3 now. Our x-axis, our y-intercept our y-intercept is now 3, and our horizontal asymptote is still the x-axis. Well, let's use a different color. We can keep track of the various transformations. So this red curve is now y equals 3 times 2 to the power x. Okay, so now our next transformation that we can consider is the negative. So negative 3 times 2 to the power x. So the negative is a reflection in the x-axis. So if we do that reflection, let's use green. So again, let's mark off a few points here on the y-axis. We now take that red curve and we just reflect it in the x-axis. So where do we end up? We end up the curve looking something like that. So y equals negative 3 times 2 to the power x. Okay, so we're getting there. So next, let's consider the translation to the right 1 unit and the translation up 2 units. So that translation up 2 units takes our horizontal asymptote and moves it up 2 units. So our horizontal asymptote is now at the line y equals 2. The translation right now takes our point 3 on the y-axis and moves it over one unit to the right. So now we're at the point, this point is actually 1, negative 3. So we can put a dotted line through the point x equals 1. So now this green curve actually it's been shifted up. It's also shifted up 2 units by mistake. So it's moved over 1 unit and shifted up 2. So we actually end up at negative 1, 1. So now this green curve has changed, has been moved, translated, and becomes this blue curve. Y equals negative 3 times 2 to the power, let's see, x minus 1, and then plus 2. Good. So one more point that might be worth considering is the new y-intercept. So the new y-intercept occurs again when x equals 0. If we plug x equals 0 into our blue function here, what do we get? We actually get 0.5. So we can do that arithmetic off to the side. Okay, so let's find our new y-intercept. So y equals negative 3 times 2. So the negative 1 plus 2. So we get negative 3 over 2 plus 2. And that's just 1 over 2. Or a half. And that's exactly what we have there. So our blue curve is the graph of our function y equals negative 3 times 2 to the power x minus 1 plus 2. So that brings us to the end of our session today. If you have any questions, give us a shout at info@raisemymarks.com or give us a call day or evening. So thank you for watching, and we look forward to hearing from you.